So last time we talked about real numbers, and we started for properties of real numbers. And I talked about commutative property, associative property, and I talk about distributive property too. And I give some examples also. Or also I starting for addition and subtraction property. So today I'm going to talk about the multiplicative and division property. So here you go. So multiplicative and division property. Any questions so far from last time? Anyone has a question from last time? The class was clear last time? No questions so far about real numbers? Okay. So today I'm going to talk about the properties of another properties for multiplication and division. So first things I have to know, A divided by B, what does that mean? What is the meaning of A divided by B? Who will give me the answer? What does that mean?
So how many times B will go into A?
A, again, what is that? A times what? A times 1 over B. A times A, yes. So A divided by B, this is mean A times 1 over B. Okay, and this is equal A over B. So this is a fraction. A divided by B is like a fraction. This is called numerator. And this is called denominator. Okay. So let's talk about the first property for multiplication. First one is said if A divided by B, the fraction A over B times the fraction C over D, such that B not equal 0. Why is not equal 0? Why B and D is not equal 0?
Because you can't divide by 0?
Yes, and they give me undefined number. Undefined number. So A over B times C over D, this is equal A times C over B times D. We multiply both numerator together and both denominator together. And this is equal AC over BD. This is called multiplying fractions. Okay, let me give an example for this. Example. Who will give me example for that? Who will give me example? Who will give me example? Sample example. Okay, I will give 2 over 3 times 5 over 7. What's the answer? Again, by using this property, we multiply the both numerator and the both denominator. So what's the answer? 2 times 5 over 3 times 7. Give me 10 over exactly 21. Angel. 10 over 21. So this is the first property. Second one. It said A divided B, A over B divided by C over D. That's the answer. So for this property is we keep the first fraction, A over B. We change the division to multiplication, and we flip the second fraction. So the flip for this one is D over AC. The answer is we again multiply the both numerator and the both denominator. A times D over B times C. Okay? So example for this. Give example. Suppose I have 2 over 3 divided by 5 over 7. The answer is, who will give an answer? And how I think for this? Again, I using this property is 2 over 3, the division. We change it to multiplication, and we flip this fraction, 7 over 5. So what's the answer? Now again, we multiply the both numerator and the both denominator. 14 over 15. Any question? This is called division fraction. Here, dividing fraction. Okay. No questions so far? Perfect. Let's go to the third. Yes. Yes. A question?
No.
Okay. So our next third one. Three. Third one said if I have two fractions, A over C plus B over C, and both of the fractions have the same denominator. Look, C and C. So the addition for the both fraction, we just add the both numerator and we keep the same denominator. So the same denominator C, we add A plus B. So here, same denominator.
Same with subtraction.
Say again.
Same with subtraction.
Yeah. The same numerator C. C, we keep the C the same, we add A plus B. Example. Suppose I have 7 over 3 plus 5 over 2. What's the answer? No, not 3, over 3. 5 over 3. What's the answer? Because we have the same denominator, so the answer, they have the fraction, the denominator is 3. Here 7 plus 5. 7 plus 5 is 12 over 3. We simplify to 4. Well, this is true. Perfect. Right. Number 4. If I have different denominator, suppose I have A over B plus C over B, and B and D not equal. So we do cross multiply. We multiply this A by D, C by D. We multiply this B by D. So the answer here, A times D plus C times B over B times D. Here, different denominator. Example. Suppose I have 2 over 3 plus 7 over 11. What is the answer? We cross multiply. That's mean 2 times what? 11 plus 7 times 3 over 11 times 3 times 11. How we think about this? Again, we multiply 2 by 11, multiply 7 by 3, 1 multiply 3 by 11. So the answer is 22 plus 7 times 3 is 21 over 33. We do summation is 43 over 33. Well, this is true. Okay, yes, advance, this is true. Any questions so far?
No questions.
Okay. Let's go to the 5th property. Suppose I have fraction look like this: A times C over B times C. Suppose my fraction look like that. So this is called, if I have common factor. Look, I have C in the denominator for this fraction, and I have C, and I have C in the numerator for this fraction, and I have the same C in the denominator for this fraction. So I can cancel the C by the C because it's the common factor. So they give me, what they give me? A over B. It's called, cancellation property. So I can cancel Can you do that with division too, or no? Yeah, you can do it with the division. You can do it with the division. So here we can cancel number that are common factor in both denominator and numerator. I give you example. Who will give an example? You want to donate, for example? Okay, I will give an example. Suppose I have 2 times 13 over 5 times 13. Look, we have common factor, the 13. So we cancel it each two together. Give me 2 over 12. Another example. Suppose I have 7 times 20 over 20 times 20. So we have cancelled the common factor. I have 20 with the 20. You give me 7 over 20. Okay. Another example. 7 times 15 over 10 times 15. So I can cancel the 15 together and they give me 7 over 10. Yeah, it turns to 1. I can it can turn to 1 or we can cancel it. Yeah, I will show you. Okay, good question. Any question before I move to the next slide? Okay. So it turns to 1 or it cancels. Look, the same example. Like 5 times 7 over 9 times 7. So the cancel means it turns to 1. This means if I want to separate this fraction to be like something like that, 5 over 9 times 7 over 7. And this fraction, they give me the same exactly like this. So 7 over 7 is 1. Is actually 1. 5 over 9 times 1. And this is give me 5 over 9. I answered your question? Okay. So the last property, number 6. So suppose if I have two fractions, a over b equal c over d. I have two fractions, okay? Then if the both fractions are equal, if this fraction, look, equal to this fraction, this means a cross b, a times d is equal to c times b. Cross multiply. This is named cross multiply. Here, this cross this equal to this cross this. So AD equal to CB. Who will give me an example for this one? Example. Who will give me an example? Give me two fractions are equal to each other, but like A and B and C and D are different numbers, but the both fractions are equal to each other. That means A times D is equal C times B. Or give me the example. 1/2. Can you make the like you send me a private message? Can you make it public message, please, to let all the students see your what you type? Because it's like private, just only I can see your message. What about the other students? They cannot see it. So here I have student. He said 1/2 is equal to 2/4. This fraction is different about this fraction, but both of them are equal. Look, this fraction A, B, C, D are different numbers, but the both fractions are equal. Let me check. If this equal, then A cross B, A times 4, must be equal to 2 times 2. And this is true because 1 times 4 is 4. And 2 times 2 is 4. So this is true. These two fractions are equal to each other. We'll give me another one. I give you this one, 3/7. So 3/7 equal to this fraction, 9/21. Since 3 times 21 is equal to 7 times 9. 3 times 21 is equal to 9 times 7. 3 times 21 is 63. And 9 times 7 is 63. So this is true. These both fractions are equal. Any questions so far? No questions. Okay. So let's go next slide. I want to teach you something new. Maybe it's new for some of you. Maybe it's not new for some of you. It's called LCD, least common. Can you go back for the? Oh yeah, sure. Here. You're welcome. Hold up. Okay. So now, for some example, another example. So some example, 5/36 times plus 7/120. Look, both this fraction, they have a hard and like, look, the number for the denominator is so large. So when you do like cross multiply 5 times 120 plus this number and this number times this number, they give me like a huge number. 5 times 120 plus 5 times 36 and 120 plus 36 times 36. I mean, they give me a huge number. There is another way you can solve something like that. It's called LCD. It's called least common denominator. So how can I solve this problem by using this method LCD? Because not all the time is easy to multiply a huge number like that. So look, We go to the 36, we take the 36 and we try to factor this number. What's the factor for 36? Or in other words, how can I, like, give me two numbers. If I multiply these two numbers, they give me 36. Okay, I will choose 6 times 6. Yes, 6 times 6. Again, I will try to factor this number to the prime factors. I mean, like, I want to factor it to the smallest number to factor. That, like, I want to look for smallest number. If I multiply these two smallest numbers, they give me the number 6. So the 6, I can, like, simplify it or factor it to 2 times 3. And again, there's another 6 here. I can factor it to 2 times 3. So the factor for 36 is 2 times 3 times 2 times 3. Let me reorder this number. 2 times 2 times 3 times 3. Is good? So first things, we're looking for two numbers. If I multiply these two numbers, I get 36. Or I can, like Martin, he said 18 times 2. This is true. If I want to use, like, for example, 18 times 2, then I have to factor this number again. What's the fact? Because the 18 is a huge number. I want to, like, looking for two numbers. If I multiply with these two numbers, they give me 18. 9 times 2 times 2. This 2 here. And the 18 here. 18. So again, the number 9, I can factor it again. I can simplify it again by 3 times 3. And this 2 send it down again. So this actually, this is similar to this, but in different numbers, different factors. Okay? Any question? And again, I take the 120, see the 120 here, the second denominator. So actually I factoring the denominator for both fractions. 36, I factor it to 2 times 2 times 3 times 3. 120, I want to factor it again. Same idea like 36. So give me two numbers. If I multiply these two numbers, they give me 120. 20 times 6. 20 times 6. This is true. Or 12 times 10. Yes, this is true. So let me take 12 times 10. Then I factor again the 12. Who will give me the factor for 12? 6 times 2. What's the factor for the 10? 5 times 2, right? The number 6, I can factor it. 3 times 2. And this 2 here, go back again here. This 2, this one. The 5, I can factor it? No, I can't factor the 5. Still keep it 5. The 2, I can factor it? No, keep it 2. Reorder it again. Keep the 2's together. 2 times 2 times 2 times 3 times 5. Is it clear? Okay. Let me delete this one. So now, the common number for both fractions, I try to cancel it. So 2 by 2. 2 by 2, 3 by 3. The rest here is number 3. The rest here is number 2 and number 5. Okay? So right now, what we have to do, we'll go back to the same question. We multiply this fraction by 2 and 5. We'll multiply hand 2 and 5. I multiply 2 times 5. And this fraction, I multiply only by 3. Times 3 times 3. Okay? So 5 times 2 is 10. Like I multiply both fractions by 10. I multiply this by 10, this by 10. Here 3, I multiply this by 3, this by 3. Okay? So now, what class is that? This is pre-calculus 195. Okay. So the 5 times 10, 36 times 10. So what I get? 5 over 36 times 10, here times 10, plus 7 times 3, 120 times 3. So now the fraction becomes so easy because both of the denominator, they will be the same. This is equal 360. This is equal 360. So we're looking for the least common denominator. See? So the least common denominator is 360. 5 times 10 is 50, plus 7 times 3 is 21. And now it's so easy to solve this fraction. 360 to the denominator. Now the numerator is 1 plus 0 is 1, 2 plus 5 is 7. Any question? This is called the least common denominator. To solve a question like the fraction, they have a hard numbers. Joanna, are you in the class or not? This is pre-calculus. It's not longer. You have to know how to fract the denominator for the first fraction, the denominator for the second fraction. After you find the factor, you cancel the common numbers. Then you multiply the both by the what the rest of the numbers. Okay. Okay, whatever you want. If you want like big number, you can do it. If you need this way, you can use this way. Any questions so far before I go to the next slide? It's clear what I did for this one. Yeah, I can wait. Yes, sure. It's not issue. Just like you have to know how to factor the denominator for the first fraction and the denominator for the second fraction. If you know how to factor, then it will be like easy. I hope it makes sense for all of you. Are you done from this slide? Can I move to the next slide? Yes. Any question for any of you? Is it clear? If it is not clear, I can repeat it again. If one has a question, don't feel shy. Ask your question. Okay. So now I can do sum for different fraction by least common denominator. Now, let me give you example. Example. This is the review example, okay? Solve this question. Minus 7/3 times 18x minus 15y. How to solve this one? This is the first one. Second question, 1/7 plus 4/9. This is review question, like last time. I talk about distributive property. To remind you, what's the distributive property? If I have real number A times parentheses B plus C, okay? So I can distribute the A inside the parentheses. This will give me A times B plus A times C. This is the distributive property. Are we solving those? Yes. You can help me. You can open the mic and help me how we can using the distributive property for the first one. Who will solve the first one? Anyone? Anyone who will solve the first one?
I can say the first step, which is to distribute
Okay.
the -7/3 into
Oh, hold on. What's your name?
Isada.
Okay. Yeah, how you first solve the first one?
So you distribute this -7/3
Over 3 times
into
what?
into 18
X.
and -15.
Okay. And negative times negative, what is the answer?
Positive.
Positive. 7/3 times what?
Half.
15y, right?
Yes.
Yes. So we can cancel the 3. We can simplify the 3 with the 18 as 9, right? No, as 6, sorry. 6. And we can simplify the 3 with the 15 as 5. So what's the answer? Minus 7 times 6 is, okay. And okay, this is minus x plus 7 times 5 is y. True. This is right, Angel. Okay. Now for the next one. Who will do the next one? Who will answer the next one?
Can I have
What's
a
your
shot? Noel?
What's your name again?
Noel?
Noel. Okay. How you solve this one?
So first we need to find the least common denominator between 7 and 9.
Okay.
And
But
that
but look, this fraction and this fraction, they have like small numbers. That
Yeah.
mean we don't have to use the least common denominator, right? We can use the cross multiply, easier, right?
yeah.
Look, the number is 1, 7, 4, 6, 9. It's like easy. So what's the idea for the cross multiply? How we can solve this by cross multiply? Yeah, Noel?
Oh, I'm sorry, repeat that. Like
How you can solve this by cross multiply? We multiply 1 by what? By
okay.
9, right? And 4 by 7 and we multiply 7 by 9. So what's the answer now?
Okay, that would be
So 1 times 9 plus 4 times 7, right?
yeah, that would be 37 over 63.
7 times 30. What is the answer?
37 over 63.
Okay, let's check. 9 plus 28. 9 plus 28 is 737. Yeah. Okay. Yes, this is true. Yeah. So because we have here a small number, so we can use the cross multiply easier.
Yeah.
Okay. Perfect. Any question so far? Here we have, I probably did something wrong. Martin, what's you did? Can you turn on the mic? Oh, okay, no problem. Okay, so any question before we go to another part of the section? Okay, let me go to the something is called real line. Real line. So what's the real line? The real line, it's like any line is a line. This line, I can represent the real number in this line by a point. So I can use this line to represent the real numbers as a point on this line, that line. And here I have a question. It's not like a function. No. So look, so what's the real line? This is the real line. Here's the real line. Here. This is the real line. Line has point, okay? 0, 1, 2, 3. So the numbers of the real numbers here, I can represent it as point. Look, 0 as a point, 1 as a point, 2 as a point, and also the 1/2 as a point, 1/4 as a point, -1, -2, -3. All of these I can represent it as a point. So the real numbers I will represent it as a point in the real line. This is called real line. I have some notes for this real line. I give you like around 1 minute to move the next slide. So look again. So the real line, it's a line. I can represent it, the real number in this line. 2, 3, etc. here -1, -2, -3, etc. So first note, we see the number A is less than the number B So suppose I have two numbers. First number is A, second number is B, and I said the number A is less than the number B. What does that mean? So that means I can denote it as inequality A less than B. And also this is mean the number B is greater than A. That means the number B is lying on the real line in the left of the number A. So suppose, for example, I want to choose the number B as 3. I want to choose the number A as number 1. So look, the number 3 is lying on the real line, the left side of 1. So this is 1, this is 3.
Open circle in 3.
Yeah. So this is 3, and this is 1. So the 3 lie on the real line, left side of number 1. Another notification. So here, number 2, B lies to the left. Of A. Second note, we said B is greater than A. This is mean B is greater than A. Okay, that's mean again the B lies to the left of A, but in different word. Would not be to be, no. B will be lying on the real line left of A. B lies to the left of A because B is greater than A. We don't have Discord for this class, but I'm going to record. I'm recording I will record every class and I will post it in the YouTube. I will make a YouTube channel and I will send you the link for like the playlist for all videos. So, okay, B is greater than A. That means B is greater than A by this inequality. This means the number B lies to the left of A. I give you example. 4 is greater than 1. This is mean 4 is greater than 1. And if I want to show these things on the real line, here, this is the 0. Here, number 1. This is number 2, 3, and this is 4. Look, 4 lies to the left of number 1. Number 4 lies to the left of, to the right, to the right. Sorry, 4 lies to the right of number 4. So B lies to the right. Thank you. Right of A. 4 lies to the right of A, and vice versa. 1 lies to the left of 4. Here, if I want to make it right, just want to show you something. Here. B is the greater. B lies to the right. Of A, or I can say A lies to the left of B. The inequality here is mean greater. B is greater than A, that means B greater than A. The inequality means here greater. Any question? Okay, so the last note, if I said, for example, B is greater than A, I said, no, I mean like, no, hold on. But this inequality here, this inequality A less than or equal B, this is mean. What does that mean? This is mean A less than B or A equal B. Any question? Okay, let me give you example. I know 7 is less than 7.4 and 7.4 is less than 8, for example, or make it more accurate, 7.4 is less than 7.5. 7.5 is less than 7.9. 7.9 is less than 8. Okay? I'm not going to use WhatsApp. I'm not going to use Discord. Okay. Second thing. I know number 2 is less than or equal to, or the square root of 2 is less than or equal to square root of 2. Okay? It makes sense. These things are less than or equal to square root of 2. 2 is less than or equal to. Any question? Okay. Let's go to the how can I represent this numbers on the real line. So again, I said 7 is less than 7.4, less than 7.5. And also I said 2 is less than or equal to. So how can I represent this in the real line? So again, 7, here is the 0. So 7, this is number 7, for example. And this is number, for example, 8, okay? So this is 7.5 in the half, in the mid between 7 and 8. So 7.4 will be here. So this is 7.4, 7.5, and this is number 7. No chatting in the chat. This is for question only. I don't want to do GC. I don't want to do WhatsApp. I want to just do the classes here in the Zoom, and then I will post the video in the YouTube. Okay?
Professor, I have a question.
What's your question? About the
Okay,
material
so-
only, the question.
Okay, so I see how like you don't want us making a group chat or whatever, but like say like whether it's like we have a question and say like you know you don't want like 1,000 emails coming at you like, okay, what is we may help with this, or we're still unclear about this. Wouldn't you want us to go to a classmate and be like, hey, like, do you know how to do this? Do you know, like, can you help me? And then whether like when we go to like the next class, you know, that we all talk about it. Because that's how it kind of was. Like, I'm not gonna say like last semester in my other class, that's how like
Sure.
we like understood it more. I don't know. I can't speak for everybody else, but I don't know. That's just me. I don't know.
But I asked you before you asked me your question. Your question is about this material or outside? I need about this thing.
No, it's fine. It's okay. I'll talk to you after class.
Okay. Okay, no problem. Okay, now let's go to another different things. It's called sets and intervals. Any question before I move to another part? Okay, sets and intervals. Okay, so what's the meaning of set? What's the meaning of set? Who heard about sets before? Sets is a collection of objects. Its point of this is interval. This is what you said. Angle is interval. So what is set? Set is just a point. Yes, like is not like for some objects like something class have students. So our class is called a set. Okay. So set is a collection of objects. So for example, for math 195 class, we have student. This is student are object inside the class. And this class is called set. I give example for set A equal 1, 2, 3, 4, 5. This is set has numbers 1, 2, 3, 4, 5. Okay. This 1, 2, 3, 4, 5 are object. This is object. So the number 1 is belongs to the number to the set A. Why? Because A1 is inside the set. Okay. But 6 is not belong to the A. Why? Because the 6 is not inside the set. Okay. Any question? Okay, let's now go to the intervals. What is intervals? First things we have to know, we have two kinds of intervals. Closed intervals and open intervals. So what's the closed intervals and what's the open intervals? Okay, so intervals it's similar to the set, but here the intervals has infinity numbers of elements inside this interval. I mean, for that, let me first explain what is the meaning of open set and closed set, and from these things, two things, you will understand what the meaning of interval. So closed set, closed interval. Suppose I have, if I have element A real number less than B, okay? Then the closed interval for A from the number A to the number B, it's consisting all numbers. It is consisting all numbers between A and B and the endpoints. I mean for the endpoints A and B. So, and it's denoted by like that. Close AB means all the elements between A and B, between this number and this number, and the endpoint A and B.
I have a question.
Yes.
Should the interval be open with parentheses because you have like a greater than sign?
Yeah. If it's open, look like different. Look like that. Close, look like that. Okay. I'm going to talk about open. So this is a closed set. A closed set means every element between the number A and the number B, and also the endpoints A and B. How can I graph this thing? Look how they graph it. This is my real line. This is the element A. It's closed inside the interval. This is the element B. It's closed inside the interval. And all the numbers between A and B here. All the numbers. Suppose I have here minus. No, I don't want to make it hard. Suppose I have A as 3, and here is 5. That means all the numbers between 3 and 5, and also 3 and 5 means 3, 3.5, 4, 4.5. All of them are 3.1, 3.2, 3.3. All the numbers between 3 and 5, and also 3 and 5. So how can I denote this? So I can denote this by this. A comma B is equal X such that X between or equal, you see the equal, A and B. So the closed interval 3, 5 is equal X such that 3 less than or equal X less than or equal 5. This is the closed interval. Any question? So the closed interval, all the elements between 3 and 5, and also 3 and 5 itself, because they are endpoints. This is called endpoints.
Does that X in
Yes.
does that X next to the inequality denote that
This
these
is
are
X
just
means,
X values?
X
Okay.
means the values, yes. Value between 3 and 5. Like I mean for X, 3.1, 3.2, 3.4, because all of these X is an element inside the 3, between 3 and 5, inside the interval. Here, for example, 3.1, 3.2, and etc. All of them. X means value, element between the 3 and 5, and also X equal to 3 and X equal to the 5, because the equal sign. Yes, the equal. I hope it makes sense. Now let's go to the open interval. The open interval, the same exactly like that, but the endpoint is not inside the interval. This is the difference. This is the only difference. The endpoint, it's not inside the interval. So open interval. It looks like this. What is the open interval? So again, if A less than B, this number is less than this number, then the open interval from A to B consists all numbers between A and B without the endpoint, without the endpoint. The endpoint is not included. That's true. I mean, for the endpoint is A and B. How I can graph it? Okay. So A comma B. How can I graph this one? So I draw a real line. This is A. This is B. A is open interval. B, this is open interval. The open means is not inside. A is not inside the interval. So this is open. This is open. Everything between A and B are inside the interval. Okay. How I can denote it for this one? Again, this is equal X. X means any value such that A less than X less than B. Here is no equal. There is no equal. See? Here is no equal. But look here back. We have equal. Here we don't have equal. A less than X less than B. This is the open interval. This is mean A and B are not including inside this interval. Again, this is equal X such that A less than X less than B. Okay, another notification. We have half open, half closed. We have half open, half closed. Okay, notification. We have like, okay, I give you another half open, half closed. Okay, notation. Here is the set description. And this is called the graph here. We graph it. So if we have something like that, A, comma B, but this is closed and this is open. If it's open in the side of A and closed in the side of B, this is mean the end point A, it's not inside the interval, but the end point B, it's inside the interval. How can I describe this one? X, any value, such that, no, it's not infinity to the B. Here between A and B, but A is not inside the interval. This is mean any value between A and B, but A it's not inside it. This is mean A does not have equal here. See, less than or equal B. Here we have equal. How we can graph this one? We have a line. A is open, but B is closed. And we have everything here between all both are including. Okay. Now your question is, if A is open and infinity, how we can describe this thing? So again, it's X such that X from A to the infinity, that means X from A to the infinity, that means any element is greater than A. How can I represent that? Any element is greater than A. This is mean the element is greater than A. All the element is greater than A to the infinity. How can I graph this one? So I draw the line. A is open, and all the elements that goes to the infinity. Yes, row. So what about this thing, minus infinity and B is closed? What is set description? Again, X such that here it says exactly all the element is less than B or equal B, because we have a closed interval. All the element is less than B or equal B. So here B, and here's the element. All the element is less than B, less than or equal B. How I can graph it? I draw the line. Here is my B. This is B, and it's closed. Why? Because it's closed interval. So closed, and all the element it's less than B. Row. empty, our element is this empty. Or equal, I mean, or equal. It makes sense? Any questions so far? No questions? Anyone has a question about this? The interval, open interval, close interval, half open, half closed. Okay, so the section is finished. We finished this section. Anyone has a question about this section? Okay, I will give you a review example for this section before we go into the next section. The review example says, how we can solve something like that? 3 over 5 minus plus 4 over 5 over 6, 7. How we can solve something like that? I give you 2 minutes and then I will start solving this question. Or I need somebody help me how to solve it. Anyone can help? Three multiplied by 5 over 3 plus 4. Yes, this is true, 100% true. Cross multiply, you can use the cross multiply too. Yes, but will be like more harder cross multiply. So, like Will he said, so cross multiply is good and easy, but the problem here, we have fraction in the denominator. So the best thing we catch, we take this one, then we take this one. I take this one and I simplify. I take this one and I simplify because I need to get something like that. One fraction plus one fraction. I don't need a fraction. I need just only one fraction and here number. That's it. So how can I simplify this one? It's like 3 times we flipped this one. How we flip it? 5 over 3. And here we can cancel this one by this one. They give me 5 only. Okay. For the second one, 5 times flip 7 over 5. What is the answer? 28 over 5. So the first one is 5 over 1. Second one is 28 over 5. 5 over 1. 28 over 5. Now cross multiply. Now look, it's so easy to do the cross multiply. Right? So the answer is 5 times 5, 25, plus 28 times 1 is 28, divided by 5 times 1 is 5. The answer is 53 over 5. It's easy. It's easier than cross multiply. If you want to do cross multiply, 3 times this fraction, 4 times this fraction, and this fraction times this fraction, and it will be like so complicated. It makes sense to all of you. Okay. Now let's go to the next section. No question. So today I'm going to post the first homework for this section. Any question before I go to the next section? Is the homework due today? No, the homework is due 1 week until next Thursday. But I prefer to start doing the homework today, because if you keep it until last day, you are not going to do it. I prefer to start doing the homework from today. Open the homework, start solving the questions. If you keep it until last day, you are not going to do it. Any question? Okay, 1.2 is exponents and radicals. We don't have homework for this week. We don't have, no homework for this week. I will post the homework today until next Thursday, due to Thursday. Okay, exponent and radical. What is the meaning of exponent? Who will give me like example for exponent? What is the meaning of exponent? Have you heard about that in high school? Exponent? Yes, exactly, 2 over 2, 2 to the power 2, or for example, 5 to the power 2, or 6 to the power something. So we are going to talk about something look like a to the power of m over n. This is what we're going to talk about in this section. Such that m over n, you see this, m over n, is rational number. What is the rational number again? Who will remind me for the rational number? Okay, I will remind you. Rational number is any number of the form m over n, such that n not equal 0, and m and n, both of them are integers. M and n are integers, and in the same time n not equal 0. This is rational number. The irrational numbers, if I cannot write any number in this ratio, for example, square root of 2, I can't write it as a fraction, look like that. Okay. So first part of this section is talk about integer exponent. What does that mean? Suppose I have 5 times 5 times 5. How can I represent this thing as exponent? Who can help me? Yes, 5 to the power 3.
5 to the cube.
5 to the power 3. Why? Because I have three bases. Okay. And all these numbers are identical. Look, 5, 5, 5, identical numbers. Yes, 125. So in general, what's the general formula? If I have a real number, if A is a real number and N is a positive number, then I can say then the nth power of A is look like A to the N. What does that mean? Like A times A times A times nth time, nth time. Like I said before, yes, look. So if I have, for example, 5 to the power 3, this is mean 5 times 5 times 5. 3 times 1, 2, 3. 3 times. Okay. This A is called base. And this N is called exponent. This is the exponent, this is the base. Okay, give you example. Example. What is 1 over 2 to the power 5? What is this equal? It is equal 1 to 1 over 2, 1 half, 1 half, 5 times 1, 2, 3, 4, 5. What does that equal? 1, 2 times 2 times 2 times 2 times 2 is, what is it? 2 times 2 times 2 times 2 times 2. 32. Yes, 1 over 32. Any question before I move? Next slide. Is it clear? So, another example. Another example. What is minus 3 to the power 4? What is that equal? Minus 3 times minus 3 times minus 3. What is the answer? 3 times 3 times 3 times 3 is 81. As minus times minus times minus times minus is positive. So the answer is positive 81. What about this? What's the answer? minus 281. Why? Because the minus outside looks like this. 3 times 3 times 3 times 3. This is equal. The minus is outside. Keep it outside. Now we multiply the 3 4 times. So look, here is minus, here is positive. Okay, we will stop up to here today. Anyone has a question before I stop recording for this class? Anyone has a question? Everything clear for now? Okay. So I want to stop recording, okay? Stop the recording. Okay. Thank you, everyone. Starting the recording right now.